Alright, so introduction to 8.6. Kind of exciting because this is your last lesson for Chapter 8, and so we'll be able to spend some time just kind of putting everything together. But 8.6, what you're going to do is you are now going to be solving rational equations. Two methods that we'll try out. First method is the cross-multiply method, and you guys know how cross-multiplying works, so that'll be pretty straightforward. The other method, the LCD, is the least common denominator method, and you actually have done this before with linear equations, so I'll just remind you about that and then show you an example. And of course, watch the videos on this as well, just for more details. When you cross-multiply, you want to use this if you have just one fraction equal to one fraction. If you have any other terms, you can't cross-multiply. So when you have a fraction equal to a fraction, you will cross-multiply to get rid of the fraction. So you cross-multiply, it takes you out of fractions. You may have to do some distributing or foiling, combining of like terms just to simplify the equation, and then it gives you something pretty nicely that you can solve for x. You don't have a fraction any longer, so it's going to seem much easier at that point. Once you do solve for x, here's another one of those mathy things where you may not have actually found the solution, so you're going to check for extraneous solutions. Alright, so quickly here we're looking at a fraction equal to a fraction. We've done quite a bit of just factoring when we can. This x squared minus 4, x plus 2, x minus 2. Let's look at it that way, and because we'll be able to do a nice little trick with this. So when you cross multiply, we're going to take 4 times the x plus 2, x minus 2 equals 8x minus 1 times x minus 2. So remember, when you cross multiply, put an equal sign in between. Sometimes people like to end up with a new fraction, but that doesn't make sense, so don't do that. At this point, what you could look for is, do you have any common factors on both sides of the equation? And if I look, I can see, well, yeah, I have an x minus 2 on both sides. Mathematically, what you can do to make our equation a little bit more simple is I can say, well, let me divide by x minus 2. Now, if I'm going to divide the left side by x minus 2, I have to divide the right side by x minus 2. And what that's going to allow me to do is now I can cancel my x minus 2's on both sides. And so we're left with 4x plus 2 equals 8 times x minus 1. We could do that again with the 4 and the 8, do a little bit of dividing, but let me just show you distributing 4x plus 8 equals 8x minus 8, and now you have a much simpler equation to work with solving for x. So you would solve for x, check for that extraneous solution, remember that's a false solution, to see if you got a real answer. Watch the videos though to see how this finishes up and what that check actually looks like, because we don't really check every single thing. There's just a couple of spot checks that we do. Alright, so I threw this slide in here just to show you guys this least common denominator method, the LCD method. You actually have been doing this. Maybe you recognize this 1/3 x plus 3 halves y equals 6. Looks a lot like standard form for your linear equations. You know, back when you did point slope, slope intercept, and standard form. And if this was standard form, you would have to get rid of your fractions, which means this is a problem and this is a problem in standard form. So what you learned how to do was multiply every single thing by whatever your denominators are. So you want to multiply by a 3 and a 2, or let's just say a 6. What that does when you multiply every single term by 6 is it kind of quite conveniently gets rid of your fractions. 6 over 1, let me do it off on the side, 6 over 1 times 1 over 3. If you multiply straight across or just do your canceling, you end up with 2. So that's a 2x plus, now 6 over 1 times the 3 halves. Multiply straight across or do the reducing, you end up with a 9y. And then 6 times 6 is 36. So we end up with no fractions. That's exactly what the LCD method is doing. You're trying to end up with no fractions. And so it's actually, I really like this method because it's quite nice. Here are some steps to follow for the LCD, or I guess I was calling it least common denominator, lowest common denominator. You use this when you want to eliminate denominators. In your steps, you have to create that LCD. What is the lowest common denominator that will make all your denominators cancel? Then you multiply every term by your LCD. You're going to be simplifying. This is where you're going to be canceling out. Your things are going to cancel in this step. And then just that same distribute and FOIL, combine like terms. You're able to solve for x, and just do that spot check for extraneous solutions. Again, watch the other videos to see what that looks like. So here's what a problem might look like using the LCD method. If you notice, you have two fractions over here equal to 6. Well, plus and then equal to 6. It's not one fraction equal to one fraction, so I'm not going to cross multiply this. I'm going to use the LCD method. By the way, LCD you can use on any problem you want. So if you want to just bypass the whole cross multiply thing and you like this method, you could just stick with this. So what you do is you kind of have to, off on the side, build the lowest common denominator. So you just look and say, well, if I have an x plus 3, I need there to be an x plus 3 in my lowest common denominator. What else do we have in our denominators? We have a 3, so I need there to be a 3. And then do we have any other denominators that I missed? Nope. So of all the denominators in our problem, you kind of put them together, no repeats, so it's in the lowest form. We have 3x plus 3. So what we're going to do is we're going to multiply our entire equation by 3x plus 3. Now this tends to get a little bit messy, so I like to do this off on the side. If you take that first term, 10 over x plus 3 times 3x plus 3, and then over 1, sometimes I put it over 1 just to remember that that is in the numerator. And when you do that, what you're going to notice is, oh look, your x plus 3's cancels. And what are you left with? 10 times 3 on the top, or 30. So that first term becomes a 30. Bring down my plus. Now I'm going to multiply the LCD, 3x plus 3, by the next term, 10 over 3. And so what's going to cancel this time? Oh yeah, those 3's cancels. That's kind of nice. So you're left with the 10 and the x plus 3. Running out of room a little bit. So this 10 over 3, we just multiplied by the LCD and we ended up with, what was that, a 10 with an x plus 3. Bring down your equal sign. Now you have to take 6 and multiply it by the same thing. So we'll do 6 times our LCD, 3x plus 3. And here you don't have any denominators, so nothing's going to cancel. So let's go ahead and multiply the 6 and the 3 together to get 18x plus 3. So in our equation, we go back and we write 18x plus 3. So we have an equation where we're done with fractions, and now is just the distributing, foiling, combining like terms piece of whatever you might see here. So you've got a 30 plus, if you distribute the 10, 10x plus 30 equals, distribute the 18, 18x plus, I think it's 54. Now you just have a regular old equation where you're just going to get your like terms together and solve for x. So you would continue solve for x and check for extraneous solutions. So that's the LCD method. Pretty slick. Again, it gets a little messy, so if it helps to just do the work off on the side to figure out what's going to cancel and get your terms, you can write them back over here and then finish up your work.